This is an introduction to complex numbers. So there's a problem in math, and it revolves around an expression like this. We cannot take the square root of a negative number because the square root implies that we're looking for a number that when multiplied by itself will equal the number underneath. So we know that the square root of 9 can be either 3 or negative 3. Okay, so we know that 3 times 3 is equal to 9, and negative 3 times negative 3 equals 9. And so we can take the square root of a positive number, but when it comes to a negative number, there is no number where if you multiplied it by itself, you would get a negative number, because any number that is a positive multiplied by itself, positive times a positive, would be a positive. And any number that is a negative multiplied by itself, a negative times a negative, is equal to a positive. So there are no real numbers that when you multiply the number by itself, it results in a negative number. And therefore, the idea of taking the square root of a negative number in the real number system would be nonsense or no solution. Okay? The problem is that there are many times in math where we encounter situations where we want to take, where the solution would be the square root of a negative number. So whenever we want to solve an equation that has x squared in it, so for example, let's say that we had x squared is equal to 25. The way that we would solve this is we would take the square root of x squared, and we know that x times x is equal to x squared, and so the square root of x squared is simply x. Algebraically, if we do the square root to one side, we have to do the square root to the other side as well. And the square root of 25 is either 5 or negative 5. And so we can solve this x squared equals 25, and the solutions are x equals 5 and x is equal to negative 5. So we have two solutions. But what if we were in this situation? What if we were in the situation where we had x squared plus 25 was equal to 0? This is a legitimate equation here. And the question is there a number that if you square it and then add 25 that you would get 0? Well, one way of approaching this solution is to subtract 25 from both sides, in which case we would have x squared is equal to negative 25. And then, of course, to solve this, we would take the square root of x squared, but then on this side, we would have to take the square root of negative 25, which is nonsense. It's impossible, no solution. Well, many mathematicians were not satisfied with stopping there. They looked into, is there a way of representing a solution to this problem? And what they came up with is the square root of negative 1. You see, we can factor a radical. For example, the square root of 12 can be written as the square root of 3 times the square root of 4. Okay? Hopefully you already know that. So we can take this square root of negative 25 and we can write it as the square root of 25 times the square root of negative 1. And we know that negative 1 times 25 is negative 25. We can take the square root of 25. Square root of 25 is 5, or negative 5, but in this case we're just going to do 5. And then what do we do with the square root of negative 1? Well, what mathematicians decided was they're going to represent the square root of negative 1 by the letter I. In the very same way pi is used to represent 3.14 and e is used to represent 2.72. So what we wind up with is that this square root of negative 25 winds up being 5i. Okay? And we could also write the square root of negative 49 as 7i. Why? Because the square root of 49 is 7 and the negative is represented by the I. And ultimately, what we have is we've come up with a form where we can actually represent a complex number as a number that does not have an I plus a number that does have an I. So the form of all complex numbers is A plus bi. And an example would be, for example, 4 plus 5i, where the 4 is called the real part and the 5i is called the imaginary part. And if we were to say what is the real part, we would say 4, and if we said what is the imaginary part, we would say 5. Okay? And so if we had negative 6 minus 3i, the real part would be negative 6, the imaginary part would be negative 3. And that's our introduction to complex numbers.